once you set up the proportion, you can really use any way you want to solve it. It doesn't matter. Some people like to cross multiply just to do the same thing every time and create a habit. That's cool. I like just to try to do it in my head if I can, and notice that 1 times 20 will get me here, or 20 divided by 20 will get me to 1. So if I just take this and divide by 20, you'll get 18 cents. Okay, coming over here, we got 16 ounces for 320. We want to know how much 1 ounce would cost, because that makes it easy to compare and see what is the better buy. Well, dividing this by 16, if I take this and divide by 16, I get 20 cents. Okay, and again, you could have cross multiplied or done whatever. And now we can compare and say, okay, this is cheaper. We're going to go with Mario instead of Luigi. Alright, last example. On a map, and you see this on maps all the time, you got scales. Even on your map on your phone, you have a scale down in the corner. 100 miles is represented by 1 inch. We want to know how many miles. Again, we're just matching up. Miles are going on top. We could have done inches on top. It didn't matter as long as we're consistent. How many miles are represented by 8.5 inches? Well, again, I'm just going to do 1 times 8.5. 100 times 8.5 will get me 850 miles. Alright, now let's flip over on the back. Basic proportion problems. Try to do these on your own. X has got to be 18. Number 9, all of a sudden, we got this x plus 7, and a lot of people are going to see this and freak out and say, oh my God, I've never seen this before. Cross multiply. We can't really do anything different. Or you could look and say 15 divided by 5 is 3. And so I know 7 times 3, this has got to be 21, and then x has got to be 14. Is all that's going to happen. Or if we cross multiply, 7 times 5 is 105. And then we got 5 times x plus 7. And we can just distribute that and set up an equation. And then solve. Subtract that from each side, so on and so forth. And we get that x has got to be 14. Okay? But we could have done it in our head from the beginning. Either way, it doesn't matter. Alright, moving on. Each rectangle, we want to know the ratio of the longer side to the shorter side. So the ratio of the longer one, which is 65, to the shorter one, 65 to 30. Piece of cake. But let's simplify it, okay? And that means just to take this and divide by something that they both have in common. I'll just use 5. If we divide everything by 5, we get 13 out of 6. We have a 13 to 6 ratio. Number 11, we want the longer side, which is 50, to the shorter side. I'm just going to simplify this, dividing everything by 10. Maybe you divided it by 2 to start with. Fine. You get down to 25 out of 20. Keep going. Divide by 5, and you get 5 out of 4. And that's as simplified as we can get. So there's a 5 to 4 ratio between the longer side to the shorter side. Now, on to the good stuff. That was just setting the foundation. Here's where the real fun happens. Are these two shapes similar? If we remember back, they look similar. They look kind of alike, but that's not exactly what we mean. When we mean similar, this is what we mean right here. This is the important part. Same angles, proportional sides, or the sides proportional. Are the angles the same? Well, no, this has got a 90-degree angle, and so we don't even need to check the sides. In fact, you can tell this is a right triangle and this is an isosceles acute triangle. They're not even the same shape. Even though they're both triangles, they're not the same shape. And so no, they're not similar because they're not the same shape. But more importantly, their angles are different. Alright, moving on to B. Here they didn't give us any information about the angles, but they look like this is just a bigger version of that triangle. And so are they similar? Well, if they're similar, the angles got to be the same. Well, we're just going to have to assume they are. And are the sides proportional? Well, let's check that out. 4 out of 12, is that the same thing as 5 out of 15? Are those two things proportional? You may know right away 4 times 3 is 12, 5 times 3 is 15. Yes, they are. If you cross multiply, you both get 60, so they're the same. You cross multiply, you get 60 and 60, they're the same. Well, let's check the third side just to be sure. Is all of these the same as 3 out of 9? Yes, again, 4 times 3, 5 times 3, 3 times 3. These are similar because the sides are proportional. Looking at example C, we don't have any information on the angles. And we're just going to assume that the angles are all the same. You know, they look like they're the same, which is not good enough, but it's all we got. But are the sides proportional? Well, let's set it up. 2, and you can pick whatever to start with, it doesn't matter. 2 out of 8, is that the same as 10 out of 40? Just make sure that I'm matching. I can't pick the top and the bottom and then do the side and the top. Just matching things up. 2, top and the bottom, top and the bottom. 2 times 4 is 8. 10 times 4 is 40. These are proportional. Well, it's got to work for all of them, though. Let's check. 5 and 20. 2 times 4, 10 times 4, 5 times 4 is working so far. 7 out of 35. 7 times 5 is 35, not 4. So all of these would have to be the same. This is not similar because the sides are not proportional. A couple of them are, but all of them have to be. And not all of the sides are proportional. So they're not similar. Alright, example 13 tells us that ABCD is similar, that little squiggly line means similar, to EFGH. Okay. If they're similar, we know the sides are proportional. So let's set up a proportion. We got 5 and we got 6. And I just started with those two because those were the only two sides that I had both numbers for. So 5 out of 6 is the same as, or is proportional to, 2 out of x. Again, I'm making sure that I match everything up. And then I can cross multiply or do whatever I want to see that here we get 12. 12 divided by 5 would be 2.4. And decimals do exist. It's okay to get a decimal. And then we'll set up another proportion to get y, 5 out of 6. And let me just switch it up just to show you we could have done this. We could have said 6 out of 5. That's okay. As long as we're consistent, we did this one over that one. So now we got to do this one on top. Y out of 10. Here, instead of cross multiplying, I'm just going to know 5 times 2 is 10. So 6 times 2, y has got to be 12. Okay, moving on. It told us that ABCD is similar to EFGH. When I'm looking at these two shapes, they look a little weird, and that's because one of them is kind of turned all around. But this is important, the way that they write this, because we can match things up with what they belong, because it's hard to kind of tell, well, what's the left side, and this is all turned around. But notice that this order matters. AB goes with EF, BC goes with FG, so on and so forth. So if we're going to say AB, 4, AB over EF is 12. Now let's do AD is 3. AD was this one and that one, so that's going to match up with E and H, which is here. So this has kind of been flipped around, is what's happened to it. But we just got to make sure we did left 4 to 12, 3 to X, and we can cross multiply. We can say 4 times 3 is 12, so 3 times 3 has got to be 9. X has got to be 9. Okay, then we need to get Y, and we're going to do the same thing. Y is DC, and DC belongs to HJ, which is 21. And we can pick any. We got several to choose from. It doesn't matter which ones we pick. Let's use BC because we hadn't used it before. We did Y on top, so let's do 5. Then BC goes with FG, which is 15. Okay, again, I'm just noticing that 5 times 3, and so this has got to be 7. Y has got to be 7. And then you'll notice as these are similar, that it's 4 times 3 is 12, 5 times 3 is 15, 3 times 3 is 9, 7 times 3 is 21. This is just 3 times bigger than that one. They're the same exact shape, same angles, but these sides are 3 times bigger. Okay. Last example, number 14. We're given 2 shapes, and we're told that they're similar. And in this case, we don't even have any numbers, but I want to show you, kind of build off what we were talking about back here, is that how these are written tells us a lot of information. It tells us that angle D is the same as angle L. Remember, in similar shapes, the angles are all the same. So angle D is equal to angle L. Angle F is equal to angle K. And angle G is equal to angle M. Okay, G goes with M, D goes with L, and F goes with K. We don't even know numbers, but we know that because they're similar. We also can say that DF, line DF, is proportional to LK, and FG, which is here, is proportional to KM. And lastly, what we do, DF, FG, so we got to do DG. DG is proportional to LM. We're just matching stuff up. Okay, and then B, you don't even have to be given a picture of anything. If I say ABC, let's just do ABCD is similar to KLMN. Not even given anything, no picture, no numbers, no nothing. If these two things are similar, we know they have the same angles. So A is the same as K. B is the same as, I'm just going to write all this out, just so you can tell the order I'm going in. A, B, C, D. K is the same, B is the same as L. C is the same as M. And D is the same as N. Okay? And then the sides, AB matches up with KL. AB matches up with KL. BC matches up with LM. CD matches up with MN. And then lastly, AD matches up with KN. AD matches up with KN. Okay, that's it for tonight's lesson and for homework. If you have any questions from watching this, go through, make a star, circle, jot a note down. You don't have to write exactly what I have. You can put additional notes, whatever you need to help you.